Let us now look at the covalent bonds, chemical makeup, and magnetic properties of the different mineral components found within most rocks, which would give these rocks their magnetic properties or lack of. All natural rocks, especially the hardest igneous and metamorphic rocks, contain silica quartz crystals woven throughout their structure, where this silica is chemically known as silicon dioxide, which cannot readily expand when exposed to rapidly increased temperatures and pressures. The chemical composition of granite is typically 70 to 77% silica, 11 to 13% aluminum, and 3 to 5% potassium oxide. While corundum happens to be a crystalline form of aluminum oxide and typically contain traces of iron, titanium, vanadium, and chromium. Generally, the magnetic susceptibility of a given rock type would be related to its content of metallic elements. Unfortunately, when most people hear of magnetic properties, they only understand magnetic attraction, but beyond ferromagnetic properties, there is also diamagnetic and paramagnetic properties, which in accordance with Lenz's laws manifest within various metallic elements or their oxides and sulfides whenever they are near electromagnets or changing magnetic fields. For example, pyrite is still very responsive and susceptible to permanence and magnetism, even though pyrite, which more commonly is known as fool's gold, is an iron sulfide mineral and not pure iron. These properties of natural stones and minerals are what facilitate the existence and efficiency of modern induction furnaces, which uses alternating electric current at ultra-high frequencies to induce heat into metals and crushed mineral ores to cast and smelt all the metals currently used across modern society. This was exclusively explained and demonstrated by Buffalo University in 2016 when they tested an ITC induction furnace to melt several rock types. As such, given that both chemistry and alchemy originated from the land of Kemet, it is likely that the Egyptians may have understood the fundamental or innate chemical, metallic, and magnetic properties of very hard rocks, and as such designed, built, and utilized tools and techniques that harness those properties and had it all working in their favor. Therefore, looking at the amazing works of the ancient Egyptians in this new context, instead of only seeing them using dolerite pounders wrapped in ropes and sticks, the creators of the pyramids may have been using rotary cutters that utilized high-frequency magnetic induction, which helped to maximize the abrasive cutting feed rate into natural stones and bedrock. Essentially, these tools would have been designed to cut using a duality of processes, using changing magnetic polarity, which would induce heat directly into the surface being cut, which on a microscopic level would make that rock surface easier to cut or grind down. This is because the heat introduced through magnetic induction would simultaneously heat or even melt the metallic mineral components in the stone and fracture or shatter and loosen some of the silica glass that held these components, all done on the microscopic scale within the rock. So, the outer surface of these rocks that was exposed to these types of tools would not have had the appearance of being burnt, but they would have a brittle and petrified feel, almost like you could use your fingernail to scrape away granite. Even though granite is 7 on the Mohs hardness scale, and a person's fingernail is only 1, which is the lowest. To end this amazing video, it should be noted that all these types of ideas will be labeled as debunked ideas, as no such magnetic tools were ever found in the archaeological records of Egypt, and the standard model suggests that the pyramid builders' slaves only had access to stone hammers and copper chisels smashing together. Nonetheless, the stone marks tell a different story. Remember to get